Welcome to the deep dive. Today, we're digging into probably the biggest tension in tech right now, AI. It's this incredible engine for efficiency, but at the same time, it's creating security risks on a scale we've just never seen before.
That tension is everything. It's really driving the entire market. I mean, you look at the numbers, something like 95% of U.S. companies are using generative AI. This is not a fringe thing anymore.
Exactly. And the adoption has just completely outrun the security.
It really has. Organizations are scrambling. The World Economic Forum's latest outlook says 66% of organizations think AI is going to have a massive impact on their cybersecurity.
Within the next year.
Within the next year.
Right.
And here's the kicker. Only 37% of them have any kind of process to check if these AI systems are secure before they're deployed.
Wow. So there's a huge gap between how much we rely on it and how prepared we are.
A massive gap.
Okay, so let's frame our deep dive today. Based on the material, we're looking at this through three lenses, right? First, how to secure the Gen AI apps we're building. Second, how to use AI to make our own security better. And third, how to defend ourselves against threats that are themselves powered by AI. We're covering the whole life cycle.
You have to. You can't really understand the problem without looking at all three angles. It's a triangle of challenges.
And as we get into this, we really want to thank our sponsors for making this deep dive possible. A huge thank you to cloudassets.vibehack.dev and www.vibehack.dev. Your support lets us bring these kinds of critical insights to our listeners.
Absolutely.
So let's start with a foundational question. I hear the terms AI security and AI safety used almost interchangeably. Can we draw a clear line between them?
Yeah, that's a great place to start. They are definitely two sides of the same coin, but they do very different jobs.
Okay.
Think of AI security as the shield. It's the technical part, protecting the AI system itself from being hacked, from tampering, from misuse.
So the classic confidentiality, integrity, availability stuff.
Exactly. It's about protecting the box the AI lives in. AI safety is. It's a much bigger idea. It's about minimizing harm and unintended consequences.
So that's where the ethics come in. The guardrails.
That's where the guardrails, the fine-tuning, all of that comes in. Making sure the system behaves responsibly, even when it sees something new. You need both to have responsible AI. You can't have one without the other.
That helps a lot. And now we're moving beyond AI that just answers questions. We're getting into what you call agentic AI. How does that change the game when the AI starts acting on its own?
Oh, it changes everything. The complexity just explodes. A generative model makes content, right? And the agent uses that model to, break down a goal into steps, call other tools, use APIs, and actually get something done in the real world.
So the attack surface isn't just a chat window anymore. An agent could be changing cloud configurations or sending money or anything.
Precisely. Gartner's predicting that a third of all enterprise software will have agentic AI in it by 2028. So you have to stop thinking just about the prompt and start thinking about tool access, identity, and what permissions that agent has.
Which leads directly to responsibility. If we're using these powerful tools, how do we know who is supposed to secure what?
You have to start with the scoping matrix. It forces you to figure out if you're a buyer or a builder.
A buyer versus a builder. Okay.
If you're a buyer, you're just consuming a service someone else built. Your responsibility for the underlying model is way lower. But you still own your data, your access controls, all of that.
But if you're a builder?
If you're a builder, you carry all of it. You're training your own models. You're responsible for the training data pipeline, the model itself, the infrastructure it runs on, the whole 9 yards. The security burden is massively higher.
Okay, let's get into the really core challenge here. What makes securing an LLM fundamentally different from securing, say, a traditional web application? What are the big ideas we need to grasp?
There are three, and they're all kind of counterintuitive if you come from a traditional software background. First, and this is a big one, LLMs are non-deterministic.
Meaning what exactly?
You can give it the exact same input twice and get two different outputs. Because of things like sampling and temperature settings, there's a degree of randomness built in.
So you can't do traditional testing. You can't just say, input A should always give me output B. That whole validation model is broken.
Completely broken. You can't rely on it for security checks. Second, and this is just as important, LLMs process all inputs with equal privilege.
Wait, so there's no firewall inside the model?
None. A user's prompt, the system instructions you wrote, a document it told up for context, It's all just tokens to the model. It has no concept of this is trusted, this is untrusted.
Which is why prompt injection is such a nightmare. You can't build a zero-trust boundary inside the model's brain, so to speak.
You can't. It's architecturally impossible. And the third piece is that LLMs are statistical pattern completion engines. They're just predicting the next most likely word. They are not performing logical deduction.
And that's where hallucination comes from.
That's the root of it. They can sound incredibly convincing while being completely factually wrong. They don't guarantee correctness.
So we have a system that's inconsistent, has no internal security boundaries, and makes statistical errors. It feels like we need something completely external to enforce logic. And that, I assume, is where automated reasoning comes in.
That's exactly it. Automated reasoning or formal verification acts as that external guardrail. It's the difference between prediction and proof.
Okay, can you use that Pythagorean theorem analogy? I found that really helpful for understanding the difference.
Sure, so machine learning might look at, say, 1,000,000 triangles and learn the patterns to predict which ones are right triangles. It might be 99.9% accurate.
But it might miss one.
It might.
Yeah.
Automated reasoning doesn't learn from examples. It uses a logical rule, A plus B equals C, to prove with mathematical certainty whether any given triangle is a right triangle. It proves it for all of them, even the ones it's never seen.
It's about having a logical proof instead of a statistical guess. Okay, let's make that concrete with the airline chatbot example.
Okay, so imagine an airline's policy is written as a formal rule. Issue a full refund if the cancellation is operational and it's not due to weather.
So the flight is canceled for maintenance. The AI says, yes, you get a refund. How does automated reasoning check that?
The AR system is like a separate verifier. It checks the facts against the rule. Is the cancellation operational? Yes. Is it not due to weather? Yes. Both conditions are true, so the AR system says valid, and the refund goes through.
Okay, but what if the AI messes up? Let's say the cancellation was due to a blizzard, but the AI hallucinates and says yes to the refund anyway.
The AR system catches it. It checks the rule. Is the cancellation operational? Maybe. But is the not due to weather condition true? No, it's false. Because one part of the AND condition fails, the whole thing is invalid. The AR system blocked the action. It prevents the wrong payment.
It's the logical backstop that the LLM just doesn't have. It's incredible. So where else is this being used in security right now?
It's huge for high-stakes stuff. In code generation, it can prove that AI-written code is memory safe. For infrastructure, tools like AWS Reachability Analyzer use it to prove, for instance, that your private database is logically impossible to reach from the internet.
And for authorization policies.
Yes, to make sure the access rules you generate don't have some hidden flaw that gives away the keys to the kingdom. It's about ensuring correctness.
All right, so we've covered securing the AI. Now let's flip the lens. How can we use AI to secure us, especially against these new AI-powered attacks?
This is where AI becomes a massive force multiplier. I mean, security teams are burning out. The scale of alerts is just impossible for humans alone.
So AI helps with the grunt work.
A lot of it. Take vulnerability analysis. An AI-based CVE analyzer can take a task that took a security analyst hours and do it in seconds. It's a huge time saver.
That's a game changer for just prioritizing patches. Now, to do this kind of analysis, the AI needs clean data. I know standardization is a huge topic here.
It's everything. And that's where the Open Cybersecurity Schema Framework, or OCSF, comes in.
Break that down for us. OCSF.
Think of it as a universal language for security data. Your firewall, your endpoint protection, your cloud logs. They all speak different dialects. OCSF translates them all into one standard format.
And why is that so important for AI?
Because AI needs structured, consistent data to work its magic. If you feed it messy, inconsistent logs, it wastes all its time just trying to figure out what it's looking at. With OCSF, a Gen AI tool can instantly understand data from any source and start correlating events, mapping them to things like the MPAR, ATT, and CK framework, and finding the real threats much, much faster.
In a security operations center, SOC, what does that look like?
It looks like automated alert triage. It looks like AI providing real-time advice to a human analyst during an investigation. It's about using AI inside your SIEM and SOAR platforms to cut through the noise and get to the signal faster.
This is clearly a complex world with evolving tools, new standards like OCSF, and deep tech like automated reasoning. And we want to again thank our sponsors for supporting this kind of deep dive. cloudassets.vibehack.dev and www.vibehack.dev. This knowledge is just so crucial.
It is. The landscape changes daily.
So let's get into some concrete defensive plays. For an organization building with Gen AI, what are the absolute Must-do best practices.
Okay, first you start with secure by design. That means security isn't an afterthought. You're building it in from day one using memory-safe languages, patching your dependencies, following frameworks like NIST SSDF.
Table stakes, really. What about controlling the AI's behavior once it's live?
That's number two. Control AI system behaviors. You need explicit guardrails. Policy limits. You need response validation, especially using automated reasoning for anything high impact. And using architectures like RAG retrieval augmented generation is key to limit what data the model can even see.
And what about the input itself, protecting against prompt injection?
Yes. Secure prompts. You need a managed catalog of approved prompts with least privilege access. And you have to aggressively sanitize all user inputs before they ever touch the model.
Last one, for these autonomous agents. How do you keep them from going rogue?
You have to prevent excessive agency. That means super granular permissions. The agent should only be able to do the absolute minimum required for its job. And you need throttles and alarms to catch any runaway loops or weird behavior.
If you zoom out from all of these specific tactics, what's the overall philosophy that ties it all together?
It's really two things working together. Defense in depth, which is just having multiple layers of security, and zero trust, which means you never trust, you always verify. You're constantly checking identity, device health, and context before granting access to anything.
Let's touch on governance. We're seeing regulations like the EU AI Act popping up everywhere. How does a company keep up?
You can't. You'll drive yourself crazy chasing every single new law. The smarter play is to build a strong AI governance program based on core principles of responsible AI. If you get the principles right, mapping to specific regulations becomes much easier.
What are some of those core principles?
Well, beyond just privacy and security, you need to focus on things like controllability. Can you stop it if you need to? Veracity and robustness. Is it accurate? And transparency. If you build your program on those pillars, you'll be in a good spot.
What about the human in the loop? Where do we draw the line? When does a human have to step in?
The line is drawn by impact. The higher the potential impact of decision on finance, on safety, on operations, the more human oversight is an absolute requirement.
So for low-level stuff, automation is fine.
Yeah, analyzing network traffic, let the AI go nuts. But for critical services, you absolutely cannot allow an AI to autonomously shut something down or make a major change without a human signing off. It has to be a partnership. AI gives you speed, the human provides judgment.
That's a perfect summary. So for everyone listening, if they need 3 immediate action items to walk away with, what are they?
Okay. Number 1, define your generative AI scope. Right now. Figure out if you're a buyer or a builder for each project. That single decision will tell you where to focus your security efforts.
Makes sense?
Number 2, implement OCSF as your standard. Start standardizing your security data now. It's foundational. It will unlock the power of any future security AI tools you bring in and just accelerate everything.
And the third one, for protecting against future threats.
Formalize AI-centric threat modeling. Start thinking about how AI could be used to attack you. Update your threat models. And critically, start planning where you'll need to use automated reasoning as a guardrail for your own high-impact agentic systems.
So it's this constant cycle. Secure the AI, use the AI to secure us, and govern the whole process.
Yeah.
And it all comes back to that partnership between machine speed and human judgment.
That's the end game. And that convergence of generative AI's creativity with automated reasoning's proof of correctness, that's what will finally let us build agentic systems that we can actually trust.
So here's the final thought for you to take away. If an AI agent can act entirely on its own inside your organization, what is the one single critical human judgment point that can never be automated? Where do you draw your final red line?
That's a powerful question to build a strategy around.
And thank you one last time to our supporters who made this all possible. cloudassist.vipap.dev and www.vipack.dev. Until next time, keep digging deeper.